Good afternoon, good morning, good evening, everyone, depending on where you have joined from. Yet another webinar from one of our favorite speakers, Chris, and today's session is about building custom vision applications. My name is Amit Bansal, and I'm just going to be your host for today's session. And we also have our moderator, Satya, who is going to help with Q&A as we move towards the end of the webinar. I guess all of you know about eDominer, SQLMaestros, DataPlatformGeeks, and everything that we do. So I'm just going to skip quickly over this slide. I am also sure that by this time you know about Data Platform Summit. This is an international learning event on Microsoft Data Platform and open source stack. Please join us this August. Conference is from 9 to 11 and pre-cons are on 7th and 8th of August. We are very grateful to our speakers, MVPs, MCMs, and all Microsoft experts who join us for this learning event once in a year in the month of August in Bangalore, which makes it one of its kind learning event with a lot of deep technical content being delivered across 5 days really, with more than 100 sessions by 60 speakers. dps10.com is where you should go and learn more about this, and there are email IDs there and phone numbers if you wish to reach out to the team. Thanks to the DPG team and the eDominer teams for helping us with so many webinars and in-person events that we are doing across India. Special thanks to Microsoft. Microsoft has been a great support to our community efforts, and let me assure all of you, this is one company that really understands communities so well. So we are always indebted to Microsoft. All of you are members of DataPlatformGeeks.com. Continue with your membership. There are a lot of learning resources there. Whenever you have time, just visit DataPlatformGeeks.com and explore the free videos, recorded webinars, hands-on labs, and a lot of past event resources that are available. Please join these groups, and Satya will just put down these URLs in the chat window. This is the group where you can ask questions and even answer a few of them from your peers. And we will also put up the group photograph in this group after the webinar is over. So please put down your words of appreciation for our speakers who are taking their time and effort delivering webinars for us. It really adds a lot of value to our work that we're doing. With this, I hand over to Chris for today's webinar. Chris, welcome once again, and thank you very much for your support and your time dedicated towards this webinar.
You're welcome, sir, and a massive thank you to you and your various teams for hosting these webinars. And I've personally been to the Data Platform Summit and absolutely love what you do down there. So keep up the good work, and I know you've got a great lineup, so you should be looking for a very, very immersive experience in August. And I also want to thank the attendees of this webinar today for attending. It's your time, so please feel free to ask questions in the chat window. Satya is going to be helping me answer some of those questions, but I will make time at the end of this session to answer your questions. So I'm just going to share my screen. Hopefully now you can see my screen. So if you just okay. So just one moment. Okay, so hopefully at this point you're all able to see my screen. I've just got a message there saying that the screen is not showing up full here maybe you have an extended screen. I do. Can you just confirm that you can see the screen with the message for the translator? Yes, perfect. Okay, right. So, welcome to this session. Before we start, I would like to bring to your attention this slide. As I'm teaching a presentation about a cognitive services subject, it makes sense to make use of cognitive services. So here, through the PowerPoint translator add-in, I'm using the speech to text translator, which hopefully will help you understand what I am saying, because sometimes even people in the US and the UK don't understand what I'm saying. So I'll just give you a moment to make a note of the URL, which is www.translate.it/AGQZE. So moving on, what are we going to cover today? Well, we're going to look at cognitive services with a very, very specific focus on the custom vision service and the associated APIs that you can use. The agenda for today is as follows. We'll start off with a brief introduction of the cognitive services. We'll then go into a specific overview of custom vision. We're then going to explore the custom vision APIs, and we will then look at creating a custom vision solution. So, for those of you that attended my session last week, you would have learned the core technologies that make up the Microsoft AI platform. This includes machine learning, the bot framework, and of course, cognitive services. So this is really just a brief recap of what cognitive services can bring to your business. So with Microsoft Cognitive Services, you've got a predefined set of APIs that you can hook into to add intelligence into your applications. You can also create your own REST APIs as well. But ultimately, with a few lines of code, you're able to bring about intelligence within the application. And that same API code can be used on iOS, or Android, or Windows. So it's extremely flexible. And it also supports a wide range of languages and platforms of your choice to code from. So whether you're into C# or Node.js, you can very easily build your own applications and hook into those APIs that we've created. It's backed by years of research in this area as part of Microsoft Research, Bing, and Azure Machine Learning. And we have a rich vein of documentation and sample codes that you can use to experiment with this. So what is the Microsoft Cognitive Service? Well, essentially, it's broken down into a number of different areas. Now, we're going to be focusing on vision, specifically custom vision, but there are other categories of vision APIs that you can use, be it the face APIs to recognize people, or indeed you can use computer vision to retrieve back descriptions and tags about images that you present to the actual computer vision service. We also have a speech service as well, which basically hears and speaks to your users by filtering noise, identifying speakers, and with a service known as LUIS, L-U-I-S, it can also help you to define intents so that users' interactions with speech can be translated into a specific intent based on colloquialisms that are found around the world. This is extended with language, where we've got translator APIs, where you can translate from one language to another, process text, and learn what users want. We also have a knowledge set of APIs that enables you to tap into the wide array of academic white papers and so forth from the web, academia, or from your own data stores. And we can also make use of the Bing search capabilities, where we can use the Bing APIs or the Bing image APIs to access billions of web pages, images, videos, and news utilizing Bing itself. So, you know, essentially we've got 5 areas that cognitive services can work within, but within each of these areas, they are broken down into very, very specific disciplines, if you will. So with speech, we've got custom recognition, speaker recognition, the speech to text API and the translator API. If we look at search, there's a Bing web search, Bing image search, video search, news search, and also an auto suggest. But today we're going to focus on the vision category on the left, where, as you can see here, we've got a wide range of APIs that are available. We're going to be focusing on custom vision. A quick note here, which is very much hot off the press. The emotion API in vision will be merging with the face API, and this is due this month. So if you are using the emotion API, you will want to go to our documentation to look at the instructions for migrating any code that you have in the emotion API to the face API. So I'd like to bring that to your attention. I kept them separate here in case any of you are using it at the moment, but the key point here is to bring your attention to the fact that the face API and the emotion API are merging. So we are going to focus specifically on custom vision. Now, with custom vision, what this enables us to do is it enables us to provide custom classification for objects that may not be recognized by the computer vision API, for example. And basically, we can then embed those classification models within our applications. So what you're going to see in this particular presentation is the fact that custom vision can either be done through a graphical user interface on the web, or you can do it programmatically through the rich vein of APIs that are available. So let's go into the custom vision overview. Let's start off by taking a look at a couple of pictures. So these are pictures that represent my passion in life after my family and AI. So I'm a musician. So for example, what we've got here is an example of a guitar and an amplifier. And essentially what we can do is we can build a custom classification model that classifies this into guitars and amplifiers. And if you think about this for a moment, there is a wide range of use cases that you can use. And I'll show you examples of this within the demo. So one example could be maybe you work in the biological field, in the area of plants, and you want to classify the different plants that you have. Maybe you work in an insurance industry and you want to be able to identify, based on a car accident, whether or not a car is a write-off or just simply has a dent. Another example could involve being able to take a picture of a product, upload it to a website, and that website can identify whether that product is part of its own product catalog or not. So there's a wide range of use cases in which this can be used. And we essentially provide the tools for building the custom image classifier. And essentially what you then do is expose these through the REST APIs and web interfaces. Now, to train the model, the classification model, if you're doing a proof of concept, you could do it from about 10 images. But if you're doing something from for a production purpose, 30 images for training should be enough. But obviously, the more images you use that reflect the different kind of scenarios for the classification that you're doing, the better. Now, at the moment, a common question we get asked is, well, hey, can we use this to perform object detection? At the moment, we don't, but it is a common request that we're looking at the moment, and hopefully we'll put this in our roadmap soon. So the key point here is the more images you use, the better the classifier will become. So the more you use it, the more the classifier will improve over time. So how does the custom vision process work? Well, effectively, what you will do is upload images. When you upload the images, you'll then build and model the image data. And this is done by tagging or classifying the images, then training the classifier, then testing the classifier, and finally evaluating the classifier results. Now, at that stage, one of two things will happen. You may repeat the process because in the evaluation of your classifier results, you've learned something new. Perhaps you've learned something new about the pictures where you want to create another classification or another tag for the objects. And then you'll repeat that process where you'll add the new tags to the images, you'll train it, you'll test it, you'll evaluate it. But eventually what you'll do is with this build and model, you'll get to a point where you're happy with it. And at that point, you move out of that loop and into using the prediction API. And you'll embed that prediction API within your application so that essentially you can upload an image, the prediction API will make use of the model that you've used, and finally you can consume the model through your application. There are a number of prerequisites with regards to the custom vision service. First of all, you need a valid Microsoft account, a Live ID, or an Azure Active Directory org ID. You need a series of images to train the classifier itself, and then a couple of separate images that then can be used to test the classifier after training itself. And as I've mentioned already, for a proof of concept approach, you probably only need 10 images to do this. And certainly in the materials that I'll be giving you to perform this yourself, you only need 10 images to work with a classifier in the lab itself. So let me give you a demonstration of how we can do this graphically. So first of all, what I'm going to do is go into Internet Explorer. And I'm just going to resize this. Okay. So first of all, we're going to go to a site called customvision.ai. And within customvision.ai, I will then authenticate against the Custom Vision service by signing in. Once we've signed in, the very first task you will do is you will create a project. So in this case, I will create a new project by clicking on the plus icon here, defining a name. So I'll call it CTO Test DPS. I can enter a project description. And then we have something here called domains. Now, domains gives an indication to the Custom Vision AI service the type of image data that you're working with. And this is broken down into food, landmarks, retail, and adult. Now, what you will also notice as well is that we have 3 at the bottom for general, landmarks, and retail. But you'll notice that there is a compact in brackets next to it. If you want to make use of edge intelligence with this classification solution, you can choose the landmarks compact, for example, or general compact, which will then allow you to export the classification model to a mobile device, be it iOS or indeed Android. Now, the downside is that the classification isn't as accurate as it would be with a full domain, but it enables you to make use of this on a mobile and gives you reasonably accurate results. In this demo, we're just going to choose general. So I'll click on create project, and then that's your project created. So if I go back to Custom Vision up here, you can see that we have the project that's empty at the moment called CTO Test DPS. And if I click on that, we get to the actual project settings. So we then have to add images. So we click on add images. We browse images here. And what I'm going to do is find some files. Whoops. So as you can see here, what we've got is a series of images to do with hemlock as a plant, and a series of images here to do with Japanese cherry. And what I'm going to do is I'm going to upload these images. And you can see the second stage is to add a tag. So I'm going to add the tag to all of these images called hemlock and upload those images. This will take a moment. And those images are uploaded. Click on done. And what you can see here is on the left-hand side, we've got the tags of all of which 10 are under hemlock. You also get an indication of how many images have been untagged. Let's add some more images again. So it's the same process where we'll tag all of these images. And you'll see now that we've got hemlock and Japanese cherry. So very easily what we can do is upload the images, tag them, and then we go to this green button here where we can train the model. And this will create the first iteration of training that image data itself. And based on this, it's given us a very, very high precision and a high recall. And that's because we provided pretty clear pictures to them. Be mindful that really to make the most of the classifier, you'll want to try and improve it by giving different views, different picture qualities of the various plants so that it can give you the recall. And ultimately, with each set of images that you upload, you'll create more iterations. So let me give you another example. So if I add an image, browse local files, and this time go to images, you can see we've got a test there. If I was to upload this, I would have to train it again, and it will create iteration number 2. So we're going to use this for testing. So let's close that. So the training has been done. We have our first iteration. You can see here that you can make an iteration of defaults, and this is useful from a programmatic perspective. If you just call the prediction and there's multiple iterations, you can set it to which one will be the default. And we have the prediction URL here, and effectively what we can do is copy these and make use of them within our applications. First of all, though, we'd like to test how it works. So effectively, what we can do is click on Quick Test. We'll browse the local file for the image. So if we go again to and within images, we've got test. And as you can see here, what we get at the bottom is the results. The probability is that it's 99.9% hemlock and 0% Japanese cherry. But what I want to do is test this a little bit. And let's do a search for images. And let's go for something that's a little bit different. So we'll save that to the desktop as plant. Go back to here, browse again. This time go to the desktop, look at the plant. And as you can see, it doesn't identify it as a Japanese cherry or a hemlock. Let's do a test on this. And again, we'll make this plant 2. And in here, we will browse the local files, pick up plant 2. And as you can see here, it's predicting that it's 51% hemlock and 0% Japanese cherry. So you can see that, you know, the probabilistic outcomes here with regards to this, and it's, I believe that's fern, but I am no plant expert. Okay, so hopefully you're getting an idea of what we can do. And effectively, within predictions, you can see the list of predictions here and the results that you get for each of the ones that we can do. And then we can, for example, tag that image, make that a fern, save and close. And basically, when we go to the training images, you'll see now that we have one for fern, but we do have to train that, oops, because it needs at least have 5 images. So I'd have to put 5 images in and then train it for it to work. And then that will create a separate iteration. Okay, so hopefully now this is giving you a good insight in how we can train images, check out the performance, pick up the predictions that have been worked on, and then perform a quick test. So let's have a look at this from an API perspective, because ultimately what we would like to do is embed this within our own custom applications. Now, in order to do this, you need to understand the type of custom vision client libraries that are available. And you've got custom vision.training, which allows you to make use of the custom vision training software developer kit so that you can access the training aspects of the custom vision website. And the second set is the custom vision.prediction client library that then allows you to programmatically predict an image against the custom vision endpoint that you've trained. And effectively, what you need to do there, and it should do this automatically, but if it doesn't, you can basically download this through the NuGet package manager and download those client libraries itself. Now, you've got to be mindful that you have to obtain a training key. Where is the training key found? Well, effectively, you can find the training key here. I'll be deleting these keys and changing them so you're unable to use them. So as you can see, we've got the training key and the prediction key here. And we can embed those keys within our application to use as an authentication mechanism against our particular custom vision solution. And that is found in the settings. So here's an example of how we can build this up using C#. So basically, you'll want to create stores in memory. And as you can see here under the class, we've got memory streams for hemlock images, a memory stream for Japanese cherry images, and we've got a memory stream for the test image as well. So the first thing is you want to bring in the objects that you're using, and we're using Microsoft.cognitive.customvision, and then create the memory streams itself. After you've done that, you need to do the API instantiation and the credentials management. So this is where you're going to do the key management, where you add your training key, or it can be actually embedded into your application. And then you instantiate the training API itself that will hold that training key. So effectively, how does that look? Well, it looks something like this. And again, what I will do is just do this here so you can see it. So within this particular project, here we've got the instantiation of custom vision. We've defined the namespace as custom vision sample, and then within here we've got the memory streams and we've got the APIs. Hopefully that will make sense. So the very first thing that we're going to do after that is we'll create a new project, and we're doing this as a command line interface. So what I'll do is I'll use console.writeLine, and from this what we're saying is we'll create a new project, and we'll then create a variable, and we'll call that variable project. And this is where we start hooking into the training API. And for this example, what we're going to do is create project, and we'll call that project my first project. Okay, so that's the code that you would need to do that. From there, what we can do then is manage the tagging. So if you remember, we did the taggings of hemlock and Japanese cherry. So we're going to do this in the new project. And from this, what we're going to do is we're going to create two variables. One we'll call hemlock tag. And with this, what we'll do is we'll call into the training API again. And this time we'll use the create tag method. And based on the project ID, we will then mark that as hemlock. Same again for this. Oh, let me just close that off. Same again, we'll create a second variable, and that variable will be the Japanese cherry tag. And again, using the training API create tag, we'll set this to in this case, we'll set it to Japanese cherry. Now, you know, if I continue typing here, we're going to be quite some time. So, in the interest of time, so hopefully what you're starting to see now is how we're using the training API and the various methods within that to actually create the project, manage the tags. Now, with the tag management in place, what you'll want to do is you'll want to basically add some images to the tags. So if we look at that, as you can see, we're using console write line, say that we're uploading images, and we are calling a function called load images from disk. Now, load images from disk appear right at the bottom here. And what this is doing is it's basically loading images from disk into the memory streams that we've created. So it's using directory get files and using a relative path, picking up the images hemlock and the images Japanese cherry that you saw there, and it's passing it into the memory stream. Now, as you can see here, it's calling a specific file to do the test, and that was found when we went into the work files under cognitive services, vision, custom vision, demos, demo 1, resources, images, test. And as you can see, the name of that file is testimage.jpg. So this is where the load images from disk comes in. So we add some images to the tasks. Now, the way that the images can be uploaded, they can either be uploaded one at a time, or they could be done as a batch. So here's the code. So we're simply using a for each loop, calling the training API, but we're creating images from data against the project ID with the images against the hemlock tag. Or for a single batch, we create images from data, and this isn't in a for each loop. So there's a number of different ways you can upload these images itself. So once that's done, you can then start training the project. And this is done with the train project method here against the current project ID itself. And with the project trained, you can basically check the progress. So this line of code here will basically give you the progress of the training, and that'll appear in the output window as we're doing it. And then we need to define that the trained endpoint that we're working on becomes the default endpoint. So this is the code using the training API update iteration method, where we're setting that training iteration as the default itself. So effectively, that's the code that you need to do the training that we've just seen. So now we want to make a prediction from it. So the first few lines of code here is not too dissimilar to what you saw earlier. So now we've got a prediction key where we'll get the prediction key, and that prediction key is found within the Custom Vision website here. And then we are creating the prediction endpoint, passing in the credentials and instantiating that API. So the next line of code will do a prediction within that project. I hope you can understand why I've switched into copy and paste here, because I don't think I would have got it done in time. But as you can see, we've got a write line method that's calling out, making a prediction in the command line interface, and the result is using an endpoint predict image method against the current project with the test image variable. And again, what we can do is loop through those results. So we can loop over each prediction and do those results. Now, the final bit of code that's in here is just simply management of the training key. So as you can see here with the get training key, we're just checking for whether it's null, whether it needs anything putting in, and we have the same line to code, but for this time, the prediction key. And then here's the load images from this. So what I'm going to do is I'm going to build this solution. Okay. Hemlock. This is a really good example, actually. So check out for basic stuff like this. Yeah, let's change the Hemlock tag there to this and rebuild that. Okay, that succeeded. So now we're ready to run this command line application. So we will start the application. And the first thing it's going to do is it's going to ask me for the training key. So this is where I will go into the Custom Vision AI website, take the training key, and enter that training key here. And it's now creating a new project. You can see the loading up here in the output window in the background. So those images are currently uploading. It's now training the models with those images. And now it's asking me to make a prediction. So again, I go back to this site, grab my prediction endpoint, and then paste that in here. So it's making a prediction, it's pulling back that test.image, and with 100% probability, it's stating that that image that's been uploaded is 100% hemlock. So we've seen an example here using a command line interface, but you can quite easily embed it with your WPF applications and so forth. So that's how you can programmatically code up your custom vision application. So the slides here really go through the separate sections of the code that I've just discussed in the actual application itself. And you will be able to get an opportunity to work with these labs, and I'll give you a link for that in a moment. So what I've just demonstrated there is how to set up custom vision programmatically. So here's the code for creating a project. Here's the code for managing tagging and uploading objects. Here's the code for uploading the images one at a time or as a batch. And that demo has been done. And here is the code for training the model and setting an iteration as a default, and how you make the predictions. So essentially, all the coding that I've just done in Visual Studio, I have broken down into separate steps in the PowerPoint so that you can take a look at them. And there's notes in the presentation pack that I've given to the team. So you saw a demo how we can use the application to train and predict a custom vision model. So if you would like to play around with this yourself, the engineering team at Microsoft Research has created Learn AI Bootcamp materials at the following URL. And this is very early on in the bootcamp materials. It's lab 1.2, 1.3, 1.4. And feel free, to go to this website and make use of it yourself. So in conclusion, what have we learned? So you now understand that cognitive services is broken down into vision, speech, language, knowledge, and search. And that our specific focus today has been on the vision aspect of cognitive services, where we've specifically focused on custom vision. And I hope now that you've got a really good sense of how custom vision can be used programmatically, or you can use this without any code at all. So the custom vision website is the place where you can manage your keys and your projects and your iterations and your predictions, but you can do this through the custom vision client libraries, which is customvision.training SDK and customvision.prediction. So that perfectly leaves me with 10 minutes. Before I go into the Q&A, I just want to thank you for your time today. Please follow me on Twitter if you want any information about updates or news that's coming out of Microsoft Research. I tend to put a lot of my slides and links to videos on linkedin.com. So by all means, follow me on that. And visit learnanalytics.microsoft.com for information about upcoming trainings and webinars from our partner network as well. So thank you very much. Let's go to the Q&A. Right. So what I'm going to do is bring this up. Okay. And Q&A. So, first question from Carl Packer. After making prediction, how can we add a bounded box around the object that has been detected? The short answer to your question is, at the moment, Custom Vision does not support object detection at the moment. So watch this space. So thanks for your question, Carl Packer. Anything else? Right. Can we license only one cognitive service like speech to text to convert thousands of audio files to text daily? What is the license cost? Naveen, I don't think Custom Vision is the tool to use for doing this. Converting audio files. Right, the quick answer for you here, and this is for everyone, is that if you go to Microsoft Cognitive Services page, and within here, so you're looking at audio files, speech to text. So I would try Bing Speech API, and you can look at the pricing. So whichever technology you use, just go to the product, click on the pricing page, and then basically choose your service, choose the currency, and what you'll get here is a breakdown of the pricing details and so forth. So Naveen, I would encourage you to explore the product website there. Okay, back to the Q&A. 2 questions. Can we license only one cognitive service? Oh, sorry, Naveen, thank you for putting that question in there. Again, that's been dealt with. I would highly recommend you go to the product group pages for the pricing. It isn't licensing as such. It's basically a subscription that you would use here. Are there any other questions? Well, thank you very much for your time today. I hope it's been useful for all. One more question. Should all trained images be of the same size and resolution? I'm assuming that's for the image that you're uploading. They don't have to be, but there are rules that surround the uploading of images. So again, what I would recommend is go to the Custom Vision documentation. That's how you'll do it. And within here, I would highly recommend go to documentation and first reason is you get the latest release notes and any issues. But if I remember rightly, no, I don't think there's limits on there. But again, just check that page, and you should be able to find it there. Okay. What I would say though is, in order for your classifier to be at its best, you really need to diversify the pictures that you use. So one final example that I will give you is this. Not pictures, we'll go into documents, GitHub. Let's go to our Learn. This is the Learn AI Bootcamp. So we have so much stuff in here. And if I go to this lab, this is a really good example of, you know, how my car looks these days. But you can see that we're trying to give examples here of different types of bumps. But if I go to images and writes off, can anyone spot the difference that could cause bias within this? So let me just put this in here. And please feel free to put this in the chat window or the Q&A window. So there's my write-offs. There's my dents. Can anyone see any particular problem or bias that could arise from this? If you'll notice, all the write-off images show the picture largely of a full car, whereas all the pictures of the dents are very close-up pictures of dents in a car. So there could be a possibility that you would upload a picture of a full car that's just got a dent, but it might be detected as a write-off. So you've got to be really mindful of bias within the training data that you can use. And the way we eradicate that is, you know, populate your AI and data science project teams with people from different backgrounds, and you get that diverse pool of knowledge and experiences that will pick that stuff up. So, you know, there's things that you need to be aware of, and I refer you to the team data science process to do that. So hopefully that just gives you a little bit of insight on, you know, how you should really think about the images that you use for training your data. So without further ado, we are at the top of the hour. If there's no more questions, I shall hand it back to Amit and the team. And thank you for having me again.